Hello everyone, welcome to my channel. This time around we're looking at elasticity and Hooke's law. What is elasticity? Elasticity is the ability of a material to regain its original shape and size after being distorted by an external force F. And the materials that has this ability of elasticity, they are known as elastic materials. Now let's quickly consider Hooke's law because we are going straight to calculation. We only want to quickly look at the summary of some terms. Now, Hooke's law Hooke's experimentally discovered that if a material that is an elastic material, whether wire or spring, is stretched or compressed by a force F, which is applied within the elastic limit of the material. That is, when the force is applied within the elastic limit of the material, the extension or compression in that material is directly proportional to the F that is causing the extension or compression. And if this applied force is removed, the material returns to its original size and shape. That is what are we saying here. Now, when you stretch or compress an elastic material, in as much that you are still doing that within the elastic limit of the material, the force that is causing the extension or the compression is directly proportional to the extension. That is, as the force is increasing, the extension or the compression will be increasing. And that is what we have in the Hooke's law, which states that provided the elastic limit is not exceeded, the extension or compression E in an elastic material is proportional to the applied force. As you can see in this diagram, this is the original length of this spring. When a single weight is applied on it, we have this extension, and when double weights are applied on it, we have this extension. So as the weights or the force are increasing, we have extension also increasing. Also take note of something. This applied force, in some explanation or description, restoring force may be used. And what is restoring force? When you are compressing or extending a material, there is a force in the material that tends to return the material to its original form. And this is force that is responsible for the elasticity in a material, and the force is known as a restoring force. And when you cause a deformation to a material, that is when you extend or compress a material, when the deformation stops, that is when you get to the extent of the deformation that the force can cause. So the force that is applied on that material is also equal to the restoring force. That is, we can refer to that state as a state of equilibrium. So at a state of equilibrium, the applied force equal to restoring force, because at that point they behave like action and reaction forces. So take note of that. If in any description we have a restoring force used, that's the reason why restoring force is used, because most time when the body is now in the state of equilibrium, restoring force is also equal to the applied force on the material. Now from Hooke's law, we have this mathematical representation, that is F is directly proportional to E, and we have constant of proportionality, which is known as a force constant. Sometimes it's called elastic constant or stiffness of a material, and it is defined as the force required to produce a unit extension, or you can as well describe it as a measure of how strong an elastic material is. Now we want to use this equation that is coming from Hooke's law in solving some problems. Now let's look at example 1. In example 1, we have a force of 40 Newton stretches an elastic spring by 2 centimeters. We have to find the constant of the spring, that is the force constant or the stiffness of the spring. Looking at the given parameters, we have the force of 40 Newton, which is causing an extension of 2 centimeters. We converted 2 centimeters to 0.02 meter because we are dealing with force. So by dividing 2 centimeters by 100, that is, you convert centimeter to meter by dividing it by 100. We are looking at K from F equal to KE. We made K the surrogate of the formula, and we have this 40 divided by 0.02, and that will give us 2000 Newton per meter. Newton per meter is the unit of force constant of a material. Now in our example 2, we have a spring of length 0.5 meter and it is stretched 0.02 meter by a force of 20 Newton. So we have to calculate its length when the applied force is 32 Newton. That is, when the force 20 Newton is replaced with 32 Newton. Now from the question, we can see the original length of the spring. We represented it with N naught, and that is given as 0.5 meter from the question. The first force applied on the material is 20 Newton, and this one gives us extension of 0.02. So they are now asking us to find the new length when the force of 32 Newton is applied. But before we can do that, we need to find the new extension. So how do we go about that? First thing to do is to find the force constant. In as much we are dealing with the same spring, the force constants remain the same thing no matter what the load is, in as much that the extension is still within the elastic limit. Now force constant K is given as F over extension, and that is what we have here. So force constant K equal to F1 over E1, and that is 20 over 0.2, that is F1 over E1, and that will give us 1000 Newton per meter. We can use this one to calculate the extension that the second force 32 Newton will produce, making it to the subject of the formula in this equation. So we have F2 over K, and that is 32 divided by 1000, and that will give us 0.02. But remember, we are going to find the new length, that is the new length produced by force 32 Newton. Remember, the original length of the spring is 0.5. Adding that to the new extension, and that will give us 0.532 meter. Okay, let's go to the next example. In our third example, we have the length of a wire is 22 centimeter when a load of 35 Newton is hanged at its end. So when the load is replaced with 50 Newton, that is 35 Newton is replaced with 50 Newton, the length of the wire turns to 25 centimeter. We have to calculate the original length, L naught, and we have to calculate the force constant of the wire. Now from the question, we have L1, that is the length produced when a load of 35 Newton is hung. So we converted this one to meter by having 0.22 meter. Now we also have the length produced when the load is replaced with 50 Newton. So we have to find the original length and the force constant of the spring. So what we just look at here is that the increase in force, that is the force 35 Newton is replaced with 50 Newton. What is the change in force? That is 50 minus 35, and that will give us 15 Newton. And also we look at what this change in force will cause to the length. That is change in length here. So that will be 25 minus 22, and that is what we have here. And that will give us 3 centimeter, which is also equal to 0.03 meter. Now, if the change in force 15 Newton will produce an extension of 0.03 meter, what extension will a 50 Newton produce? Remember that this is directly proportional, that is F is directly proportional to E, which means as F is increasing, E is also increasing. So that's why we were able to apply direct proportionality approach here. That is 50 Newton is producing 0.03 meter extension. So 50 Newton will produce what? So we just cross multiply. That's why we have a 50 multiplied by 0.03 divided by 15, and that will give us a 0.1. As you can see here, 50 multiplied by 0.03 divided by 15, and that will give us a 0.1 meter. That is the extension that the force 50 Newton will produce. You can as well use force 35 Newton here and to give us a particular extension. Okay, let's now see how to calculate our original length. If 50 Newton force will produce an extension of 0.1 meter, and this same 50 Newton force is what makes the length of the material to be 0.25 meter. So definitely the extension will be the new length caused by, the original length will be the new length caused by 50 Newton minus the extension caused by 50 Newton. And that is what we did here. And we have a 0.25 minus 0.1, and that is equal to 0.15 meter, which is equal to 15 centimeter. Now, the B part of the equation, the B part of the example asks us to find the force constant K. And remember, from F equal to KE, K will be equal to F over E. And if 50 Newton can produce an extension of 0.1, it means the force constant of the material will be 50 divided by 0.1, and that will be 500 Newton per meter. Sorry for that. 500, the answer is 500 Newton per meter. That is the unit of force constant. With this, we come to the end of this video. Please, if you have any question, please feel free to drop your question at the comment section, and the question will be attended to. And if this video has helped you one way or the other, please try and like the video, and also click a subscribe button to have access to our subsequent video. Thanks for watching.